This project's been a long time in the making. It was one of my first big epoxy projects, and it was almost my last. It started with picking up these amazing spalted hard maple slabs that remain to this day some of the coolest slabs I've ever had my hands on. In my old shop, I didn't have as many large format tools, so I had to get creative in flattening these beasts. I'm not sure if any of you have ever worked with hard maple, but it's a bear. I started by setting up my router with this awesome 2.5-inch flattening bit and building a simple sled. You measure the maximum distance you can get the bit away from the shoe of the router. I measured the slab to see how thick it was in its rough state, and I transferred these measurements to the rails of the flattening jig. I used a couple of clamps as guides to get the rails properly spaced from the top of the workbench. I screwed the rails into the side of the workbench and leveled them to the top of the already leveled workbench and to each other. The maple slab had a pretty big warp in it, so I used a couple of little shims to kind of stabilize it so I didn't end up with a potato chip after flattening the slab. Using the sled, I slowly worked down the surface of the slab a little bit at a time to avoid bogging down the router running that huge bit. Flattening a slab this way is really messy. If I wasn't working in the middle of the night, I probably would have done this outside. But even with the careful leveling and flattening of the slab, there were still track marks. To avoid these catching on the bed of my planer in the next step, I went over the slab with a hand plane to knock down the tracks. This next step is something I regret looking back at, but it was the best option at the time. Like I said, I didn't have any of my large format tools, so I had to figure out a way to flatten and remove material from the face of a huge slab. Since all I had was a little 12-inch lunchbox planer, I ripped the slabs into more manageable pieces and used sled to keep them ultra flat. It was also very messy. After all that planing, which may have messed up the jointed edge that I had cut on the track saw, I double-checked the edge to make sure that it was still square and cleaned it up with the hand plane as necessary before rejoining the boards with floating tenons. I was really careful in marking for the floating tenons to ensure that all the imperfections in the wood lined up so the joint was near seamless. The character of these slabs was the most important part to me, and although it could hide the seam, any inconsistencies in the knots or the spalting would be easily picked up in the finished piece. I left the panels to dry overnight, and then, let's just say, the shenanigans ensued. Although these slabs were live edge, the way they were milled didn't give me a live edge for the whole length of the slab. I traced a line that followed the organic line of the natural edge and removed material to continue the contours of the natural edge across the entire length of the panel, giving me effectively a faux live edge where needed. It's important if you were to try to do this for an entire panel that you at least use the outside edge of the tree so the sapwood can be seen, otherwise it looks awkward and clearly fake. I used a flap disc to remove material. If I had a carving disc, that probably would have been a more effective way to remove material. I also carved in a few notches just because it was my first time working with epoxy to make sure there were some areas for there to be more surface contact between the epoxy and the live edge of the slab. So I laid out the slabs on a piece of melamine that I'd cut slightly larger than the size of the finished door I was aiming to build. I then marked the slabs off the melamine to transfer this size onto the slabs, and I used a track saw to trim them down and square them up. I see a lot of makers using fancy Tyvek tape to ensure the epoxy releases from melamine, but packing tape does basically the same thing and it's way cheaper. You can actually get 6 rolls of packing tape off Amazon for the price of like half a roll of Tyvek. I rolled out 2 rolls at a time to cover my melamine substrate before pre-drilling and screwing in the sides of the form. It was also my first time using this quick change pre-drill drive a screw thingy from Rockler I've always seen Norm Abrams use, and I was unnecessarily excited to show it off. The next important step was leveling the form. Epoxy is a liquid and it will naturally find level, but your wood won't. So make sure your form is level before pouring epoxy or you'll end up with a wedge instead of a beautiful epoxy river. I also took this opportunity to caulk the seams and round them over with a beading tool. I dreaded springing a leak with all this expensive epoxy and I was overly cautious, but of course, I still sprung a little leak. Once the slabs were in the form, I used some cutoffs as cauls to clamp down the slabs before pouring the epoxy to avoid them from floating and to avoid as much epoxy as I could from getting under the slabs and having to remove that later. I should have used a caulk dam looking back and just put a bead of caulk along that edge, but hindsight's 2020. Next, I measured the average width and depth of the gap between the two slabs to estimate how much epoxy I would need. If you need a reminder of the formula for volume, it's height times width times depth. But if you need the reminder for how to convert cubic inches into liters, ask Google, I'm not your dad. I tinted my epoxy to a blue-green color as I knew it would provide great contrast to the color the wood was going to end up. Using a color wheel to figure out complementing and contrasting colors can be fun in designing a project. I actually talked about this a little bit on a recent episode on my Sunday live stream, Mo and Joe. You can check that out if you have any questions, or let me know in the comments if you think it's something that deserves a video of its own. According to my calculations, I was going to need more epoxy than my little mixing measuring container could hold, so I transferred the epoxy into a larger, brand new bucket to pour from. I wanted all the colors to homogenize a little bit in the bucket before pouring, and this way I could also give everything a last final stir before pouring. You could also mix your epoxy in smaller batches and mix colors or pour from different ends and do all kinds of things to mix up with the colors. I just wanted contrast. After pouring all the epoxy and filling a few voids in the panel, I went over the whole thing with a heat gun to pop any bubbles. Thinner, deep-set epoxy lets bubbles naturally rise to the surface and pop, but this step is necessary if you want a smooth surface on the pour. But after that, everything went wrong. Deep-set epoxy takes 3 to 7 days to set up, and of course, there were a couple scorchers that summer that came in that period. I ran the AC in the shop the whole time, and maybe it could have been a bad batch, but for one reason or another, the epoxy failed. Epoxy and hardener cause an exothermic reaction, and if they try to cure in too high of a temperature, either due to the environment or the heat created by the reaction, the whole thing can become a sticky mess like this. I scraped out all the gummy epoxy I could and poured again. This was a costly mistake, and one I would not soon forget. Next came the daunting matter of getting a finishable surface out of this panel. This gummy mess is like trying to get a finishable surface out of a panel covered in ½ an inch of that sticker residue. I have to admit, after ruining a few tools and a few pairs of pants, I was down, but not out.
One eternity later.
Oh, jeez. That's so big. This half-finished panel sat in my shed for nearly 2 years, and one move and one shop later, I returned to it. It seems that even overthermed epoxy eventually cures, and I really wanted to finish this door. It seemed like a great test for the new Mercadero system I was trying out to see if I could finish the entire surface without completely ruining my new shop. But if anyone has a large format belt sander they're looking to unload in the Midwest, but I might know a guy who could be interested. This side's even worse. On the really bad side of the panel, I didn't so much flatten the surface as just carve off all the bad epoxy. It took me probably 2 or 3 nights to chip away at what had built up in some areas to be almost ½ an inch of mostly cured epoxy. It was not fun, but through the process I did find my new favorite sander. The Mercaderos and Merca 6-inch sanding mesh discs are my new favorites, and I didn't even know having a favorite sander was a thing people could do. After getting the entire surface roughly sanded to 80 grit, I poured water onto the slab to highlight any rough spots and popped the grain before taking the panel up to the 220 grit finish sanding. After both sides of the panel were smooth and sanded 220 grit, I cut the edges of the panel parallel using a track saw and cut both ends square, being careful to preserve as much material as I possibly could, and then gave it a final sanding to 400 grit before applying finish. Watching my channel for a while, you've probably noticed me go through a few favorite finishes. There's a lot of good stuff out there, and I'll continue to recommend a few of my favorite products. This Danish teak oil is a pretty good place to start though, if you need a bulletproof finish that's easy to apply to bring that like showstopper warmth out of a project, and that's really what I was going for with this door. With the door finished, it was time to work on the critical measurements for installing the barn door hardware. The first step was measuring the height from the top of the door frame to the finished floor, and the height of the door. This barn door hardware for K & Crowder has specific instructions around how much to then offset this measurement from the ground to mark for the center of the track.
After doing some basic calculations, I marked the area above the door and used a laser level to give myself a level reference line. I then marked all of the stud locations along that line I would need for securing the beam I would install to offset the door off the wall the 3 3/4 inches I would need for it to clear the foundation. Before installing the beam, I pre-drilled and countersunk for all the lags. That would make it a little bit easier while I was up on the ladder. And I also marked the center line of the beam so that it would line up with my reference line on the wall. This would eventually be the center line for the railing of the door. The 3 3/4 inch offset for the door actually made my life a little bit easier because I could use the 3/4 inch MDF face of the beam as a template for pre-drilling the holes for the threaded inserts I would use to attach the railings. I marked each hole in the railing with a Sharpie, then pre-drilled them at the drill press before temporarily attaching them to the 2x4 beam. I then used these holes as templates to pre-drill for the threaded inserts. From there, it was simply a matter of screwing in the railing using the very nicely machined provided hardware and stainless steel bolts. On doors wider than 1 3/4 inches, the aluminum channel for the bottom guide can be inset into the door, but since I had lost much of the thickness through cleaning up that epoxy mess, I simply attached the guide to the bottom of my panel using the provided screws, and also attached the top guides using these really nice stainless steel screws. Tip for installing stainless steel screws: use a little bit of wax so that they go in without stripping out the heads. After test fitting the door, I could mark and drill for the bottom guide and install that into the floor, as well as installing the lift protection guides to keep the door from coming up off of the rails when it's pushed. This kit from K&N Crowder also comes with these awesome little bumpers to keep the door from coming off the railing. It could have been a simple stop, but K&N Crowder goes the extra mile to make everything about this hardware kit look and feel premium. I've linked below to the hardware kit that I used to install this door. The door looks and functions amazing, but I think it's still missing something. Emily Craft Supplies recently reached out to me and offered to make me this awesome Woodwork Life branding kit, and call me vain, but this seemed like the perfect place to try it out. They make a self-heating and a torch-heated version of this branding iron, and they're both solid brass CNC cut and fantastic quality. If you want to pick up your own Maker's Mark, I dropped a link to their website and their Etsy page in the description down below. This whole thing may be a little bit unnecessary, but it's awesome to have such a nice door to block out that ugly back door to the garage now. It really makes my shop feel more like a self-contained space. I love this hardware from K&N Crowder, and I'm so happy to have these slabs now displayed in my shop. Thanks for watching, and I hope you enjoyed this project. Be sure to hit that like button and subscribe if you want to see more projects like this. And remember to keep your tools sharp, keep your mind sharper.